Hello students, I am Mrs. Rima Shah Vora from Deccan Education Society, Brihan Maharashtra College of Commerce, Pune. I teach mathematics and statistics, and today we are going to cover the topic assignment problem and sequencing, which is the chapter number 7 from maths paper 2. Students, what is the meaning of assignment? Assignment means to assign something, assign certain job or allocate some job to a person. For example, if you see your day-to-day life example in your school days, what your class teacher would do, assign certain job to some people so that the job is done efficiently and hassle-free. For example, a person is a monitor, somebody takes care of the locker of the classroom, somebody takes care of the charts in the classroom, and so on. Secondly, if you want to travel from place A to place B, always if we have 3 to 4 routes, we will try to cover the distance in shortest time and with minimum resources. So we will decide which route to take according to that. Thirdly, if you want to, in any business, if we have, any big company will assign you a job according to your qualification and based on your efficiency. So it is very important that what you are doing. Then secondly, we also need to make sure in this that any business person will, what will he do? Try to minimize the cost and try to maximize the profit. So keeping all these things in mind, we are going to make the assignments. For that, now we will move on to the PowerPoint presentation.
So assignment problem is a special type of problem which deals with allocation of various resources to various activities on one-to-one basis. It is done in such a way that the total cost or time involved in the process is minimum or the total profit is maximum. The conditions over here are number of jobs is equal to the number of machines or workers. Each worker or machine is assigned to only one job. Each worker or machine is independently capable of handling any job. Objective of the assignment is clearly specified, that is minimizing or maximizing profit or minimizing cost. So based on that, we are going to solve the problems and keep all these conditions in mind. So one job is allotted to only one machine. So for that, students, we use the Hungarian method. First, in the Hungarian method is an optimization algorithm that solves an assignment problem. So Hungarian method is based on the following. Any positive or negative is added to every element of any row or column in the given cost matrix. An assignment that minimizes the total cost in the original matrix also minimizes the total cost in the revised matrix. If an assignment problem, a solution having zero total cost of assignment is an optimal solution. So let us see the steps how to solve the Hungarian method. Step 1 is subtract the minimum element in each row of the cost matrix from all the elements in the respective row. This is called as row minimization technique. We will find out the minimum element in the particular row, subtract all the elements from that particular element. Step 2, now after the row is done, we go for the column. So that is called as column minimization technique. Same thing, in each and every column, find the minimum number and then subtract. Step 3 is starting with the first row, examine the rows one by one until a row containing exactly single zero is found. So make an assignment by marking it in a square box. Okay. Then cross all the zeros in the respective column in which the assignment was made. This eliminates the possibility of making further assignment in that column. Similarly, we'll do for the same thing for column. After examining all the rows, repeat the same procedure for all the columns. So in columns also we are going to do the same thing. If we find 1 0, assign it, mark it with a box, okay, and in that particular row we will cancel out all the zeros. So if the 0 is marked in row, cancel all the zeros in column. If the 0 is marked in column, cancel all the zeros in the row. Continue these successive operations on rows and columns until all the zeros have been either assigned or crossed out and there is exactly one assignment in each row and in each column. In such case, optimal solution is obtained because every row or every column has only one and one assignment. If this doesn't happen, then there may be some rows or columns without assignments, that is, total number of marked zeros is less than the order of the cost matrix. In such case, we proceed to the next step. Draw the least possible number of horizontal and vertical lines to cover all zeros. This can be done as follows. So remember these points if the assignment is not optimal. Put a tick mark for the rows in which no assignment has been made. Put the tick mark in the columns having zeros in the marked rows. Then put a tick mark for rows which contain assignments in marked columns. Repeat 2 and 3 until the chain of marking is completed. Draw straight lines through marked columns. Draw straight lines through unmarked rows. So students, these all things by just reading you all are not going to understand, but when we do the problem, I'm sure you all will definitely understand, but keep these things in mind for now. By this way, we draw the minimum number of horizontal and vertical lines required to cover all zeros. If the number of lines is less than the order of the matrix, then there is no solution. And if the minimum number of lines is equal to the order of the matrix, then there is a solution and it is optimal. When we draw the lines, the number of lines has to be equal to the order of the matrix. If not, then we have to do the following procedure. If minimum number of lines is less than order of the matrix, then select the smallest element not covered by any of the lines of the table. Subtract this value from all the uncovered elements in the matrix and add it to all those elements which lie at the intersection of horizontal and vertical lines. So these are called as rules of zero. When we can cover smallest element, subtract all the smallest element, keep the covered elements as it is, and the intersection, we are going to add that smallest element. Again, you will understand this when with the proper example. Now we will repeat step number 4, 5 and 6 until we get the number of lines equal to the order of the matrix and till we get the optimal solution. Now, after doing all of these things, we get exactly 1 mark 0 in each row and each column of the cost matrix. The assignment schedule corresponding to these zeros is the optimal assignment. So by now, students, you all have understood that it is going to be a matrix form of a thing. Let us see the example. A job production unit has 4 jobs, A, B, C and D, which can be manufactured on each of the 4 machines, P, Q, R and S. The processing cost of each job for each machine is given in the following table. Now the table is there. You can see there are 4 rows and 4 columns. So it is a square matrix. Find the optimal assignment to minimize the total processing cost. So each job P, Q, R, S we will assign to each machine. Let us see the solution. So by using the Hungarian method, first step is subtract the smallest element of each row from every element of that row. So this is the original matrix which we already have. This we have just written for our reference over here. We don't need to write it twice. Now make the same matrix in the next step. Okay, so now look at the first row. The smallest element I can see is 25. Subtract 25 from each and every element. So 31 minus 25 is 6. 25 minus 25 is 0. 25 minus 33 minus 25 is 8. And 29 minus 25 is 4. Similarly, in the next row, we can see that smallest element is 21. So subtract it. We get 4, 3, 2 and 0. Third row, the smallest element I can see is 19. So subtract 19 from each and every element. So we get 0, 2, 4 and 5. Last row, now the smallest element is 34. So subtract it, we get 4, 2, 0 and 6. Once the row minimum is done, we have to see the column minimum. Now see over here in first column, the smallest element is 0. So anything minus 0 will remain the same thing. So no changes in column 1. Column 2 also has minimum element 0. Column 3 also has minimum element 0. And column 4 also has minimum element 0. So the elements, the next matrix after reducing is going to be the same. So now we are ready to cover all zeros by minimum number of horizontal and vertical lines. As the minimum number of straight lines required to cover all zeros in the assignment problem equals the number of rows or columns. Now see here, if I want to cover this 0, there is only 1 row, 1 0 in first row, 1 0 in second row, 1 0 in third row and 1 0 in fourth row. So 4 lines I will draw and all my zeros are covered. So it is equal, therefore the maximum, the optimal solution is obtained. After doing that, we have to now assign the zeros. So we will write down the matrix again. Now in the first row only 1 0, so mark it with a box. Here this 0 will be marked, here this 0 will be marked, and in the last row this 0 is marked. Now observe that each and every job is been assigned to only one machine. So the optimal solution has reached. So we are going to write P goes to 2, Q goes to 4, R goes to 1 and S goes to 3. Once you obtain this from the last matrix, you're going to write these numbers from the first matrix that we had started with. So the numbers over there, like the intersection of pth row and second column will be 25. The intersection of qth row and fourth row is 21. You can check the original matrix. Rth row and first column is 19 and sth row and third column is 34. Once you write the processing cost and then lastly you have to just add it. So the total minimum processing cost is rupees 99 after adding all the processing costs. And so this is done by the Hungarian method. Now let us go for the next example. A plant manager has 4 subordinates and 4 tasks to be performed. The subordinates differ in efficiency and the tasks differ in their intrinsic difficulty. This estimate of times each man would take to perform each task is given in the effectiveness matrix below. This is the matrix given to you. Again, you can see that there are 4 jobs or 4 managers and 4 machines. Okay. How should the task be allocated one to a man as to minimize the total man hours? Let us use that now. Use the Hungarian method. The first step is by the row minimum technique. Now in the first row you can see that the minimum element is 7. Subtract 7 from each and every element. We get 0, 18, 19 and 3. In the second row the minimum element is 3. Subtracting 3 we get 9, 24, 0 and 22. Third row the minimum row is 14. So we get 23, 4, 3 and 0. In the last row the minimum element is 9. Subtracting 9 from each and every element we get 9, 16, 14 and 0. Once this is done, now we go for the column minimization technique. So now subtracting each and every element by the smallest element in that column. Check in the first, third and the fourth columns. The minimum elements are 0, 0 and 0 respectively. So these 3 columns will remain same. Now in the second column, the minimum element is 4. So subtracting 4 from each and every element, we get 14, 20, 0 and 12 respectively. Now we have obtained the minimum matrix by row and column reduction method. Now assigning through zeros. So we are going to assign 0 to everyone. So let us see, first row has only 1 0. So assign it. There is no other 0 in that column. Let us go for the second row. There is only 1 0. So assign it. There is no other 0 in that column. Let us go for the third row. There are 2 zeros. So we will leave it for now. We will go for the fourth row. Only 1 0 is there. So assign it. Now you can see in the fourth column there is 1 more 0. So we will cross it. Now going back to the third row. Now only 1 0 is there because this is been crossed. So mark it. So now each row and each column contains an assignment. Hence optimal solution is obtained and the optimal assignment is as follows. So you can see over here that A is going for 1, B is going for 3, C is going for 2 and D is going for 4. After you write this, then you will go back to the original matrix. So the numbers are 7, 3, 18 and 9. Adding it, we get the total cost as 37. So this is the way the work can be done efficiently. Let us see the next example. A dairy plant has 5 milk tankers, 1, 2, 3, 4 and 5. These milk tankers are to be used on 5 delivery routes A, B, C, D and E. The distance in kilometers between the dairy plant and the delivery routes are given in the following distance matrix. This is the matrix given to you. It has 5 milk tankers and 5 routes. So how should the milk tankers be assigned to the chilling center so as to minimize the distance traveled? First is the row minimum technique. So find out the smallest element from each row. Look at the first row. The smallest element is 120. Subtracting 120 we get 30, 0, 55, 60 and 80. Second row, the smallest element is 110. Subtracting 110 from every element, we get 15, 0, 10, 40 and 55. Third row, the smallest element is 100. So subtracting we get 30, 0, 45, 60 and 75. Next row, smallest element is 40. So subtracting 40 we get 0, 0, 30, 30 and 60. Last row, the smallest element is 25. After subtracting, we get 20, 0, 35, 45 and 70. Now we go for the column minimization technique. So check in the first column, the smallest element is 0. Second column also smallest element is 0. Third column, the smallest element is 10. So let us subtract. We get 45, 0, 35, 20 and 25. Next column, the smallest element is 30. So after subtracting, we get 30, 10, 30, 0 and 15. Last column, we get the smallest element as 55. So after subtracting, the next column is 25, 0, 15, 5 and 15. After doing this, now we need to make the assignments. So assigning through zeros, this was the matrix which we got previously. So you will write down again, okay, and then in the next, the new matrix, you all are going to make the assignment. So let us use these rules. First of all, first 0 will be marked because here only 1 0 is there. Now in this column you can see so many zeros, so put a cross mark for each and every 0. Then second row there are 2 zeros. Third row there is no 0. Fourth row 2. So fifth row doesn't have any zeros. So now we'll go back to the second row. Second row 2 zeros are there. You can assign any 1 0 whatever you feel like. Okay, so if you have assigned this, cancel the other one. Next you assign in this row. So if you have selected this, cancel this one. Okay, now mark the rows in which no assignment has been made. So put a tick mark over here, no assignment in E row. Then C row also there is no assignment, so put a tick mark. Then mark the column having zeros in the marked rows. So this is the column. Okay, next is mark rows which contain assignment in marked columns. So we get this row, A row. Now you will put a line over here where there are no tick marks. Okay, so after doing that, now these are the minimum number of lines which have been drawn. Now look over here, you can see that there are 3 lines only, 1, 2 and 3, but the order of the matrix is 5. So we need to move on to the next step. So all zeros can be covered using 4 lines. Therefore number of lines required is equal to 4 and order of matrix is 5. Hence the number of lines required is not equal to order of matrix. Therefore we continue to the next step to create additional zeros. So find the smallest element, smallest uncovered element, that is 15, subtract it from all the uncovered elements and add it to all the elements which lie at the intersection of 2 lines, and the other elements on the lines remain unchanged. So see over here students, these are the uncovered elements, that is the numbers which don't have any marking on it. Okay, then find out the smallest element amongst these. The smallest is 15. So we will subtract 15 from all the uncovered elements. These are the covered elements. So leave the covered elements as it is. Now see this number and this, they are the intersected ones. So here we will add 15. So see the new matrix which we obtain after subtracting: 15 0 30 15 10, 15 15 0 10 0, 15 0 20 15 0, 0 15 20 0 5, 5 0 10 0 0. So the green ones which are marked have been changed after subtracting. The black ones are kept as it is because they are not changed, and the red ones are done after adding it. So this is just for your reference, so you know what has happened exactly. Now in the next step, assigning through zeros, we get. So now let us check the first row, only 1 0, so assign it. Are there any zeros in that column? Yes, so cross it. Now second row has 2 zeros, so we will leave it. In the third row you can see only 1 0, so assign it. Cancel the other zeros in that particular column. Now we go for the fourth row. 2 zeros are there, and in the fifth row 1 0 is there. So we will leave the 2 zeros right now and we will go for the fifth row. We have marked this, so cross the other 0. And now going back, so mark the 1 0 remaining here and the other 0 remaining in the D row. Okay, so once this is done, you can see that 5 assignments are done: 1 2 3 4 and 5. Now each row and each column contains an assignment, hence optimal solution is obtained, and the optimal solution is A is assigned to 2, B is assigned to 3, C is assigned to 5, D is assigned to 1 and E is assigned to 4. From the original matrix we get 120, 120, 170, 40 and 70. So total is 520. Minimum distance travelled is 520 kilometers. In this way we can solve the assignment problem by Hungarian method. Now we are going to see some special types of problems. First is the maximization problem. Assignment problem may deal with maximization of the objective function. To solve such a problem, we need to convert it to minimization so that we can solve it using Hungarian method. This conversion of minimization problem can be done in either of the following ways: by subtracting all the elements from the largest element of the matrix, by multiplying all the elements by the matrix by -1. So we usually use the first method. First method is very simple. You will find out the largest element from the entire matrix, subtract the element from all those elements, okay, and then it will be turned to minimization, and by the usual Hungarian method we are going to solve it. Second, then this equivalent minimization problem can be solved by Hungarian method. Second type is unbalanced assignment problem. An unbalanced problem is one in which the number of resources is not equal to the number of activities. That is, the cost of the matrix of an assignment problem is not a square matrix. If you see that it is not a square matrix, that is, number of rows is not equal to number of columns, then you will add a dummy row or dummy column, whatever is missing over there, and in that row or column, all the entries will be 0. Okay, and then by usual Hungarian method, we are going to solve it. Next type is restricted assignment problem. Such problems can be solved by assigning a very high cost, that is infinite cost, to the restricted cell. Some assignments are not done in the beginning, that is if they feel that there is no efficiency of the machine or the person, then it is not allotted. So what we do is we allot it and give it a high cost, that is infinity, and then by regular Hungarian method we solve it. So 3 methods you will remember: maximization, unbalanced, and restricted. Let us see the example. 5 different machines can do any of the 5 required jobs with different profits resulting from each assignment as shown below. So these are the assignments. Jobs are there 5 and there are 5 machines. Find the optimal assignment schedule. Now here, this maximization problem can be converted into equivalent minimization problem by subtracting all the matrix elements from the largest element, which is 62. Then the resulting matrix is. So this is the original matrix on the left hand side. Now the maximum element over here you can see is 62. So subtracting 62 from each and every element, 62 minus 30, 62 minus 37, 62 minus 40, 62 minus 28 and 62 minus 40. So the resulting answers we are getting in the next step, that is 32, 25, 22, 34 and 22. Then in the second row same. So third row also same, 22, 30, 29, 32 and 27. Fourth row 37, 24, 22, 26, 26. Last row is 33, 0, 21, 28 and 23. So after subtracting 62 from each and every row, we have obtained a minimum matrix. So now we can use the Hungarian method easily because it has been converted to a minimization problem. Subtract the smallest element of each row from every element of that row. So subtracting 22 from the first row, we get 10, 3, 0, 12, 0. Subtracting 22 from the second row also, so we get 0, 16, 13, 19 and 4. Subtracting 22 from the third row, we get 0, 8, 7, 10 and 5. Subtracting 22 from the fourth row, we get 15, 2, 0, 4 and 4. Last row, 0 is the minimum number, so the last row will remain as it is, 33, 0, 21, 28 and 23. Now we have to go for column minimum technique. In the first column, minimum element is 0. Second column, minimum element is 0. Third column, minimum element is 0. And last column, minimum element is 0. So first, second, third and fifth columns will remain same. Only in the fourth column, there will be some changes because the minimum element is 4. So let us do that now. After subtracting the columns, we'll get 10, 0, 0, 15, 33, 3, 16, 8, 2, 0. Third column is 0, 13, 7, 0, 21. And fourth column now will change. So 8, 15, 6, 0, 24, 0, 4, 5, 4 and 23. You don't need to show the subtraction. You can directly go for the matrix. We have just mentioned over here so that you all understand right now. Okay, now both row and column minimum techniques are done. So now we'll go for the assignment. So draw minimum number of lines, horizontal and vertical, that are required to cover all zeros. So we are going to cover all zeros by drawing minimum number of lines. How to do that? First of all, assign the zeros. In the first row, there are 2 zeros. So we will leave it. Second row has 1 0. So mark it. Third row, second row we have marked it. So we'll cancel this. Third row has 2 zeros. So we will leave it for now. And then fifth row, we have 1 0. So mark it. And then there are no zeros over here. So here we have marked it. There are no other zeros over here. Okay. Now we need to do the assignment in the first row. Now this is cancelled. So we are going to allot this and mark this. Now there are only 4 jobs that are assigned, but the order of the matrix is 5. So we need to cover it by the minimum number of rows and columns so that we get the optimal solution. So by using the technique of marking the rows, row number 2, 3 and column numbers 1 are marked, and then we will try to cover all the zeros by drawing minimum lines. So we will draw a line over here then this line, and this line. Now as you can see, there are only 4 lines and the order of the matrix is 5. Now look at the uncovered elements. These are the uncovered elements. Smallest element over here is 4. So we will subtract 4 from each of the uncovered elements. The covered elements will remain as it is. Now the intersected ones are this, and this elements. So we are going to add 4 over there. So we will get 12, 9, 11, 0. You can see on the right hand side of your screen 0, 4, 3, 2 and 1. All these elements are same. So we just copy it down as it is. Now the intersected ones will be 10 plus 4 is 14, 15 plus 4 is 19 and the last is 33 plus 4 is 37. So now again we will try to cover all the zeros. First row 2 zeros, second row 2 zeros, third row 1 0. So mark it. There is one more 0 over here. So put a cross mark over there. Then we will go for fourth row. Again 2 zeros. So leave it. Fifth row has 1 0. There is no other 0 in the column. So mark it. Then we will mark this one. It has 2 again. So mark this one which is 0. Again we will put a cross mark over there. Now we will go for the next row. Again it has 2. So we will mark this one. Okay. Put a cross mark wherever required. And then lastly this. So now you can see that there are 5 zeros assigned. So therefore optimal assignment can be made. An optimal solution is obtained as follows. 1 is assigned to C, 2 is assigned to E, 3 is assigned to A, 4 is assigned to D, and 5 is assigned to B. And the profit is discussed over here. So the total profit is 214 after adding all the figures. We'll go for the next problem now. 4 new machines M1, M2, M3 and M4 are to be installed in a machine shop. There are 5 vacant places A, B, C, D and E available. Because of the limited space, machine M2 cannot be placed at C and M3 cannot be placed at A. The cost matrix is given below. The assignments are not done over here as you can see. So this is a restricted problem. Okay, so find the optimal assignment schedule. Now as discussed earlier, if the assignment is not made, we are going to put it as infinity and then solve. Observe that the number of rows is not equal to number of columns in the above matrix. Therefore, it is an unbalanced assignment problem. It can be balanced by introducing a dummy machine M5 with 0 cost. So here 5 places were given and only 4 machines. So the row was missing. So add a row with particular 0. Also the restricted is there. So we will add infinity. So also it is a restricted assignment problem. Assign infinity here and here. Okay. Now it is infinity is added. So it has become minimum and also it has become balanced. So let us use the smallest element row minimization technique. First row, the smallest element is 4. Subtract 4 from all the elements, we get 0, 2, 6, 1 and 2. Second row, the smallest element is 4. So we subtracted 3, 0, 1, infinity, 1 and 0. Third row, the smallest element is 2. So after subtracting, we get 4, 7, 4, 0. And next row, the smallest element is 2. So we get 7, 1, 5, 0, 1. And in the last row, we keep it as it is. Now, whenever row is added, we do not do the column technique. And whenever a column is added, we do not do the row technique because the minimum element will be 0. Okay. Assigning through zeros, we get first row, only 1 0. So mark it. There is one more 0 in that column. So again, put a cross mark over there. Second row, there are 2 zeros, leave it. Next row, there is 1 0. So mark it. Cancel out the other zeros in that column. Then mark the next 0. Cancel out this 0. Then now we see that one more 0 is remaining. So mark it. Okay. Therefore, optimal assignment can be made. Optimal solution is shown as below because all the 5 were marked. In each and every row, there was only one assignment. So M1 goes to A, M2 goes to B, M3 goes to E, M4 goes to D, and M5 goes to C. From the original matrix, we write 4, 4, 2, 2, 0. Adding it up, we get total profit is rupees 12.
Okay, students, so we have covered the topic of assignment problem in this session. And we have also seen how to solve it by Hungarian method. And then the special types of assignment problems, that is maximization method. So we will just subtract the maximum element from the entire matrix, get it into minimum form and then use the Hungarian method. Second is restricted. So we just assign the highest infinity cost to it and then solve it by Hungarian method. And the last one is unbalanced. So if any row or column is missing, that is if the matrix is not a square matrix, then add a dummy row or column whichever is missing and then continue by the Hungarian method. So students, you can go through the solved examples of your textbook, solve the exercise 7.1 and then you can go for miscellaneous problems. Okay, all the best students. Thank you.